Good evening. My name is Paul Williams. I heard about Divergence just randomly searching on the internet. My background, I've had a lot of different jobs. Started out in the biomedical field, wanted to be a doctor. From there, ended up being a stockbroker. I was talking to Shravan and Beth last week. I've done a lot of concert work as far as concert promotion, been a door guy in Dallas for a while, but always had a passion for science, always wanted some type of technical work to do. And so kind of my journey with all of this, I started out in R, teaching myself, and I think a lot of my classmates know this, I started out in R teaching myself data science because I just always had a passion. Again, as I said, for science, and in science, any science, math and data is everything. So coming to Divergence, the first major hurdle was learning Python. And so I kind of really struggled with Python. I'm getting better every day. It's something you practice, and you eventually, you'll get good at it eventually. So I worked on my project in Python and just running some models. And, a lot of it, reverse engineering. To be honest with you, I used to have a online marketing agency, and a lot of that is just looking at what your competitor is doing, figuring out their code, their source code, and making it work for you. So, with my data set, what I'm looking at is Banco. Let me get to the next slide. You know my data now. So Banco de Portugal. They have some telemarketing data that's available from the University of California, and the primary goal here, as they've given you all these variables that you can kind of read through, is to figure out if a person will subscribe to a term deposit. So in American terms, a term deposit is a CD. So that's just putting money into a bank so it grows a little bit of interest and going from there. So it's kind of looking at this, as you can see, the nice thing about all of this is my data is primarily categorical. There's different categories. It's a lot of data. It's kind of mixed matched, but some of it maybe not relative to subscribing to a term loan or a CD. But as we keep going here, we kind of get to the more, what I would say, important stuff as far as variables or features with the employment variation rate, which is interesting. Of course, if you don't have people on the phone calling people to try to get them to deposit money, then of course that would be an issue. The consumer price index and confidence index, and also Euribor, which is the intra-bank loan rate, which always affects the interest that you'll get on a CD or a term deposit. So getting started we're going to kind of skip to my code now. I approach this in a sense of first looking at, just general numerical exploratory data analysis, and then from there looking at some visual stuff. I'll kind of get back to the slide here in a second. This is a heat map, so the most interesting thing to notice is that out of all those variables I just discussed, there's like nothing there. So this was automatically, as I'm going through this process of like, why am I not getting the rest of my variables here? That's because they are categorical, not numerical. So let me try to blow up. This is an actual heat map where I went into my variables and I did a get dummies to make it numerical. So let me get to my code.
Is that your BMW?
That's mine. Oh, that's the BMW I'm going to get once I get this data science job. Eventually, down the line. That's runs forward. Let's see here. Okay, so getting into, okay, you guys see that? You can't see that, can you?
Drag and drop it.
Oh, I see that. So you guys have maybe Alt-Tab or something?
Oh, yeah.
Driver.
Alt-Tab.
No,
Now
sorry.
go back to display.
Okay.
Back to display. It's a mirror. Go back to back on and go to display.
Oh, gotcha. And do mirror?
Yeah, do it.
Okay. Okay, I guess we'll just have to switch back.
Yeah, just pull up your.
Okay, there we go. Can you guys see that? You can see that. Okay. So, starting out, I tried to import everything I thought I was going to be using for the project, just to kind of keep everything organized. Read in the data. Oh, you know what? I forgot. I said we were going to look at the heat map. Let me go to that. I'm going to kind of skip around here. So, one, got to this heat map. Not a lot of variables there. Did an initial get dummies to turn everything into numerical data. So that increased my columns from like, I want to say, okay, is it 21 columns? And I went to 65. So again, not really knowing if this is something I should be doing, but it made sense because of course I'm trying to get data into my models. So going to a larger heat map, an actual heat map with all the variables. And this may be kind of hard to see. So you can, here you have age, and then most importantly you have year data, time data, so the month, August, April, June, July, what have you. And then some education data, and then most importantly that economic data here. So the nice thing about doing the get dummies is it turned my target variable into yes or no, which is right here, and then also here. And then so, just looking at colors, I tried to figure out, and this could be for future analysis, I tried to figure out, what's really important, because eventually, as I'm training a model, I probably want to eliminate some of these things. Most likely, I don't really think that income, or I'm sorry, a profession had a lot to do with if the person's buying into a CD. So anyway, going here, you can tell that there's a lot of variation here with the heat map of month. So it looks like people are actually buying or submitting stuff into the term deposit. It looks like in the spring and in the winter. And then going up here, there's clearly something going on with people deciding, of course, whether or not they want to buy a CD based upon the interest rate. So that makes sense. And also the consumer price index and their confidence to buy. So that was kind of cool, looking at that. Then as we go into, and I did the visualization immediately just so I could kind of figure out what's going on. Going into some of the numerical exploratory or EDA exploratory data analysis, let's see here. So I started to notice there were a lot of, this is kind of deceptive, but there's a lot of unknown values throughout the data. I kind of figured that out, one, from trying to do, the calling the head and tail of the data frame, but then also just honestly going, uploading, it's about 44,000 rows, so just uploading or downloading the data into Numbers or Excel, just like hopscotching through to see what's going on. So, as I started going through the data, or the data frame, I decided to go ahead and replace all of the unknown values as a null value. And then I looked at that to kind of figure out, okay, how many null values do I actually have? Because maybe I can remove that data from the data frame. And then you'll see here, trying to keep everything, although I could have gotten rid of the education column, that's a lot of rows. So for default education, if I removed all of those rows, it would, maybe go from like 44,000 to maybe like 28,000 rows. So that wasn't good for me. I wanted to try to keep everything. From there, there was one odd column with, I believe, if someone was contacted or not, their duration, and that value was odd. It was like 99. They had coded it as 999. So I said, for those rows, let me see how many of those there are, and then I removed them. It changed the shape. I went from 41,000 to around 39,000 rows, and then we'll skip the visual analysis because we went through that. Let's see here. If we get into, so basically what we're dealing with here is a categorical analysis or problem. So I'm trying to figure out, yes, are you going to subscribe to a CD or a term deposit or no? So with that being said, that's supervised machine learning, so I decided to look at support vector machines and as well logistic regression and k-nearest neighbors. So going into that, I think I started out with support vector machines just because, can you guys see this? Okay, there we go. I started out with this just because it's kind of like, when I read about it in layman's terms, it was like, it kind of has a lot of regression already built into it. And it's a machine, and I'm doing machine learning, so I was like, let's try it out, let's see what happens. So split my data, doing train test split. First off, I formed a pipeline, went through, and then printed out my accuracy score, which I got 0.89, so that's pretty good for prediction. And then I just kept going through and just iterating on my own with the code to try to figure out what would be the best. So this is actually doing that for k-nearest neighbors after I went through and tried to figure out what the best n value was for neighbors. I didn't really know, honestly, if this was correct, but I noticed that the testing and training accuracy was somewhere around 55, 58, so I went back up into my data and just tried out all of those here with k-nearest neighbors apparently being the best at 58 because I got, there's just less decimal places there, so it's potentially was accurate. I think, yeah, because it's 0.9138 versus 0.9130. So from there, yeah, so those were the models that I basically built. I think the next step for me would be further. I know I have a logistic regression model here, and that was around
SVM, logistic, and k-nearest neighbors.
And k-nearest neighbors, yeah. So logistic was at 0.912, which was not, logistic regression was at 0.912, which is not as good. And then I also, with the strategy for imputation for all the data, I tried to, when I first started out, I tried to, if you look at the code a little bit more closely, I tried to do most frequent versus the mean for imputation, and initially that really didn't have a huge effect on the data, so I just left it at most frequent. Yeah, so that's 3 models that I primarily worked with. I think eventually, just based upon the project that we were doing, I would try to do some type of clustering and feed it back into the model. But again, I think supervised learning, because I already had categorical data, was the best route to go. Getting back to presentation. Okay, thank you. So, further exploration and implications. I think looking at the heat map, another thing that was really important is the variation in employees and also the duration of the call, which kind of makes sense. So if someone is on the phone, they keep them on the phone, and the employees experience, then of course they're more likely to purchase a CD. Also, so moving forward in the future, because this is a data set that I plan to work on just to train myself, honestly, is looking at removing the default and education columns, as I said earlier. I would like to do some feature engineering with, maybe looking at the Eurobore rates for 1 and 2 month rates. That is a little bit tough with this data just because it's not actual time series data like per day, so I would have to maybe take an average of the Eurobore rate for the month, or even looking at say like a stock exchange rate. I'd have to take the average for the month, so that makes for a little bit more variation. In the future, I would like to do some cross-validation. This research does come from an academic paper. Apparently, the best model that they used was a neural network, so I would like to try a neural network as well. Then, of course, get to Pundelik and Ratik level and actually make a resting API. And then, of course, keep studying. More data camp. Just for you guys, I can't recommend data camp enough. Of course, we had all the resources that Siobhan gave us, but I basically learned a lot about supervised learning within 2 weeks using data camp. So for Muhammad and Ring, definitely they can work in data camp. The next step, trying to get into competing in the category competitions. That's a big deal. There's a competition out there for like $1 million for Zito. I mean, ends in 2019, but yeah, just continuing to explore and try to become a data scientist or